does this equation represent a function? And then is that function a one-to-one function? Let's check it out. On our graph, here is the parabola, y equals 2x squared plus 5. It is going to be a function because it passes the vertical line test. However, its inverse will not be a function because it fails the horizontal line test. So it is a function, but not a one-to-one function. And since we know that it is a function, remember we can replace this y with the notation f of x, just denoting that this for sure is going to be a function. Each x has its own y value. No x value has duplicate y values to go along with it. Now let's just discuss the domain and range of this function. So our domain is a description of the x values. So this graph, the parabola goes out forever to the sides, never stopping anywhere. So the domain is negative infinity to positive infinity, or all real numbers. Our range, however, a description of the y values or how we're going up and down, the graph does not go forever down. Its lowest point is actually at 5, so it hits 5, and then it goes up forever from there, up to infinity. We already said that this function, its inverse, is not going to be a function, but we can still write the equation of its inverse. Remember that the inverse involves switching the x and the y, and then solving for y. So to solve for y, I'm going to have to subtract 5, divide by 2, and then to get rid of the square, I will square root both sides with a plus or minus here in the front. So my inverse of f of x, written as f negative 1 of x, is equal to plus or minus the square root of x minus 5 over 2. And I've typed in the positive and the negative square roots here into my y equals so that I can take a look at the graph. Notice that the graph, the sideways parabola, does not pass the vertical line test. That's why the function, its inverse, is not a function. And also recall, a function and its inverse are reflections of each other through the diagonal line y equals x. And that appears to be what's happening here, is that our inverse is flipping right across this line y equals x and giving us that sideways parabola like that. And also take note that essentially our domain and range of the original function flip-flop for the inverse. The range is now all real numbers. It goes forever up and down. And the domain starts at the domain starts at positive 5 and goes forever to the right towards the infinities. Here's a new function, g of x, which when we graph this 3x minus 4 is a line, so it passes the vertical and the horizontal line test. So this is a function and a one-to-one function. And also because it is a line going something like this, its domain is all real numbers. It goes forever left and right, and its range is also all real numbers because it goes forever up and down. Let's try composing these two functions, putting the effects of one function into another. So this expression here says g following f of negative 4. So we need to do f of negative 4 first. So when I plug in negative 4 in for x into our f function, it's going to look like this. Order of operations says I need to do exponents first. Negative 4 squared is 16. Times 2 is 32, plus 5 is 37. Now I'll take that 37 and plug it into the g function. So 3 times 37 minus 4 is equal to 107. Now with this composition, notice we don't have any value for x. So when I do g of f of x, I actually need to take the entire f of x function and plug it into the g function. So this entire thing is coming in here. So this will become 3 times 2x squared plus 5 minus 4. And then I should probably simplify that doing the distributive property. 6x squared plus 15 minus 4. Combining like terms would be 6x squared plus 11. Here's our last function we'll deal with, the absolute value function. Now I know this is a function because absolute value makes a v on our graph, which passes the vertical line test. So let's say I've got this function and I know h of x is 12. I want to figure out what value of x gives me that 12 as an answer. So to solve this equation, I need to get the sticks by themselves by adding 5 to both sides. So this tells me my absolute value falls 17 places away from 0. So this 2x minus 7 could fall at 17, or it could also fall at negative 17. And then I just solve these equations for x. And negative 5 and positive 12 are our two values that will work in our original function. Real quickly, let's talk about if these are inequalities and not an equation. So let's say this is less than 12. I still add 5 to both sides, which will be less than 17. And so now when I split up into my two inequalities, I'm going to keep that less than sign, but when I make it negative 17, when I say it falls at negative 17, we have to flip that inequality sign around. So over on this side, we're going to get x is less than 2, and on the other side, we're going to get x is greater than negative 5. And here we are on my number line. I've circled 2, circled negative 5, and now we get to decide which way to shade. If I want x is less than 2, that means I'm going to the left of 2, and if I want x is greater than negative 5, that means I'm going to the right of negative 5. So there's my solution set. Any number in between negative 5 and positive 2 will work in that original inequality.